Day 459 of doing a LeetCode problem every day until I get a job.
All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3,477 fruits in the baskets 2. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, comment, subscribe, and if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. And don't forget to share. Now let's see what the question says. You are given two arrays of integers, fruits, and baskets, each of length n, where fruits of I represents the quantity of the ith type of fruit, and baskets of j represents the capacity of the jth basket. From left to right, place the fruits according to these rules. Each fruit type must be placed in the leftmost available basket with the capacity greater than or equal to the quantity of that fruit type. Each basket can hold only one type of fruit. If a fruit type cannot be placed in a basket, it remains unplaced. Return the number of fruits that remain unplaced after all possible allocations are made. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input fruits equals an array of integers 4, 2, and 5, and baskets equals an array of integers 3, 5, and 1. Our output is 1. So let's take a look at these explanations so we can see how they got this output from this input. So the explanation says fruits of 0 equals 4, so it is placed in baskets of 1, which equals 5. So we take this fruit right here and we place it in this basket, right? Because it says each fruit must be placed in the basket leftmost available, or placed in the leftmost available basket with a capacity greater than or equal to the quantity of that fruit. So these represents the quantity. These baskets represent how many fruits can be held in the basket, right? So if the quantity is less than the amount of fruit that can be held in the basket, then that means the fruit will fit in the basket. So since this fruit has a quantity of 4, it can fit in a basket that can hold 5 fruits. So since we want to put it in the leftmost available baskets, that's why we put it in 5 instead of 4, because 5 is the leftmost available basket, right? So we put this 4 and 5. Boom. So all of the 4 fruits fit into this basket. So now we move on to the next fruit. It said fruits of 1, which equals 2, is placed in baskets of 0, which equals 3. So once again, we're going to place it in the leftmost available basket. And each basket can only hold one type of fruit. So now, since we're on at the fruit that has 2, there's only 2 fruits, has a quantity of 2. This basket is already full, so we're only left to choose from this basket and this basket. We want the leftmost, so we're going to choose this basket that's available. So we put these 2 fruits in this basket that can hold 3 fruits. So now we have these 4 fruits in this basket that can hold 5 fruits, and we have these 2 fruits in this basket that can hold 3 fruits. Now we can't mix fruits in the same basket, so now we're left with this 5, but this basket can only hold 4 fruits. It can't hold 5 fruits. So since it can't hold 5 fruits, or excuse me, since this can't hold 5 fruits, that means it's unplaced. It says if a fruit type cannot be placed in any basket, it remains unplaced, and we want to return the number of fruits that remain unplaced after all possible allocations are made. So since this is the only fruit that cannot be placed or is unplaced, our output is 1, because we were able to place these 2 fruits, but this leftover fruit was left unplaced, and it's only 1 fruit that's left unplaced, so that's why our output is 1. So let's take a look at example 2, where we could fit all of the fruits. So in example 2, we have our input fruits equals an array of integers 3, 6, and 1. Baskets equals an array of integers 6, 4, and 7. The output is 0. Explanation says fruits of 0 equals 3 is placed in baskets of 0, which equals 6. So we can place these 3 fruits in this basket because this basket can hold up to 6 fruits, and we only have 3 of them, so we could just put 3 in this basket. Boom. Then we have fruits of I, which equals 6, cannot be placed in basket of 1 because that equals 4 and it has insufficient capacity, but it can be placed in the next available basket, which is baskets of 2, which equals 7. So we take these 6 fruits and we place it in this basket right here. Boom. Now we have these 2 fruits are taken care of in their respective baskets, right? We have the 3 fruits in this basket, and we have the 6 fruits in this basket, which leaves us with this last fruit. It's only 1 fruit. Fruits of 2, which equals 1, is placed in baskets of 1, which equals 4. So we could take this, fruits of 2, which equals 1, is placed in baskets of 1, which equals 4. So we take this fruit right here, it's only 1. This basket can hold up to 7 fruits, so we can easily store just 1. So we take this 1 fruit and put it in this basket. And since all of the fruits are successfully placed, we return 0 because there are no unplaced fruits. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Y'all, solution is not that difficult at all. So let's get started. Now, the first thing we need to do is we need to create a variable that's going to track how many fruits were successfully placed into the baskets. So for that, we could just declare a variable, and we could call it place count, and we could set that equal to start. And once again, this is going to keep count of how many fruits we were able to place thus far. Then we need to make a mutable copy of the baskets array so we can mark baskets as used. So we're going to declare a variable called b and set that equal to baskets, and that's going to allow us to mutate the baskets in B when we store them in B. Boom. Then we need to iterate over each fruit in the given order, so we could say for fn fruits. Boom. Then we need to try to place the current fruit in the first available basket that it can fit in. So we're going to say for I and 0 less than sign b count, we're going to open up the brackets. And if the basket can hold this fruit, meaning the capacity is greater than or equal to the fruit size, we handle that by saying if b square bracket I is greater than or equal to f, then we open up the brackets and we mark this basket as used and the capacity to 0 so it can't be used again. So now we're going to set, that's why we need to make this mutatable, because once we put the fruit in the basket, we're going to change its capacity to 0. So that's going to make sure we don't use it again. So we're going to say b of I equals 0. Boom. Then we're going to count the fruit as placed. So we're going to increase the place count by saying place count plus equals 1. Boom. Then we need to stop checking more baskets for this fruit because it's already placed. And we could come right here and we could just say break. Boom. Now all we need to do is return how many fruits could not be placed. So this where it may get tricky, but it's not tricky, but you may have to put some thought in to figure this out. But what we have to do is we need to return the fruits dot count minus the place count, and that's going to get us how many fruits were not able to be placed, or how many unplaced fruits there are. So that should work. Let's run it. Make sure it runs before we submit it. Unknown out network error. Try reloading page. Let me try again before I reload. Let's see. And it's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 2 milliseconds beats 80% of users. Not bad at all, y'all. So with that being said, that concludes our lesson for today. And I hope y'all learned something. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.